It's done.
Good morning, everyone. I see we still have some people pouring in, so we'll get started here in just a minute. All right, well, it seems the flow is slowed on those entering the room, so we'll get started here to make sure we keep ourselves on schedule. Welcome everyone back to the second day of the TESC conference virtual this year, 2020. Thank you all for attending and taking time to come in. I hope you intended to be in session 3C, new ideas about bikes and pedestrians at intersections. If not, take the time to go find the correct room that you want to be in. My name is Joe Rusevich. I'm on the steering committee here of the TESC, and I think we have a great session here for you guys today to kick off day 2. I see we do have over 100 attendees in on the call, so welcome. Probably one of the better attended ones. I don't think first sessions in the morning are this well attended while we're in person, so good to see everyone's doing well this morning on the second day of TESC. First session here we have, our first presentation is going to be from Katie Sawyer on NCHRP Report 926. Katie Sawyer is a licensed civil engineer with more than 15 years of experience delivering multimodal transportation projects. She specializes in the design and construction of active transportation and traffic safety improvement projects. As a former municipal engineer, Katie has insight into the planning, design, maintenance, and operations of city transportation systems. She is also an associate member of the National Committee on Uniform Traffic Control Devices, where she helps to advance the adoption of complete streets principles in the transportation profession. So Katie, please go ahead and take it away and share your presentation.
Thanks, Joe. Excited to be here today to talk more about bike and pedestrian safety at intersections. In a little bit, Bastion's going to dive into sort of the micro level of designing intersections and improving safety for vulnerable users. But first, I'm going to talk a little bit more on the macro scale, and I'm going to do a summary of the NCHRP Report 926, Guidance to Improving Pedestrian and Bicycle Safety at Intersections. For those who aren't familiar, the NCHRP is a kind of a research arm of DOTs. They're funded by AASHTO and member states, administered by the Transportation Research Board, National Academy of Sciences. So they kind of help select research and guide, what is being researched. But really, this is a collaboration between DOTs who have a lot of, issues that they need researched and connecting them with research centers that can help answer some questions. So that's sort of the background behind the NCHRP if you aren't familiar. This particular guide was led by University of North Carolina's Highway Safety Research Center with additional research support by Tool Design and Kittleson and Associates. So I'm going to walk you through this guide. I think it's a really great guide for practitioners. A lot of us have had questions over the years of suitable countermeasures and how effective they are with things like Vision Zero and toward zero and safe system approaches that are becoming very popular. I think all practitioners could use some more help on determining what are the most effective countermeasures for increasing pedestrian and bicycle safety at intersections. So some background and context, of course, the data behind what we're doing. In the 1970s, overall fatalities on our streets started to see a decline until about the mid-2000s. At that point, we start to see a trend upward in overall crash fatalities. However, when you look at those overall crashes that are occurring, the number of pedestrian and bicycle fatalities are increasing. So between, if you look at the chart on the right, between 2010 and 2016, the number of total roadway fatalities increased by 15%. However, the number of pedestrian fatalities increased by 41%, and the number of bicyclist fatalities increased by 37%. So what that translates to today is that about 18% of crashes that are occurring on our roads fatalities are happening to bikes and pedestrians, even though they only make up about 4% of the total trips on our system. And so that's a huge injustice when you think about, our most vulnerable users and also the amount of funding that we're putting towards transportation safety projects. Even though they're making up about 18% of those fatalities, typically only 4 to 5% of federal funding is going specifically to bike and pedestrian safety. So that's sort of the impetus for this research and seeing how we can improve bike and pedestrian safety. So why intersections? Intersections are where most of the crashes occur. Data shows that about 27% of pedestrian fatalities and 38% of cyclist fatalities are happening at intersections. I think we all can recognize that intersections are very dangerous places for all users because of the conflicts that happen there, but they're more dangerous for bikes and pedestrians. So the report kind of dives into the research that's out there. Urban areas are seeing more of the crashes, of course, which is kind of reasonable to assume. So about 80% of crashes are happening in urban environments. I think it's important to note that while 18% of fatalities are happening to bikes and peds nationwide, in certain cities, that number jumps from 25% to 45%. So in some cities, over half of fatalities are happening to bikes and pedestrians. And so, left turning maneuvers happening by motorists are one of the most prevalent risk factors, or, one of the prevalent conflicts that are occurring. They're also happening, 64 of these fatalities, 64% of these fatalities are happening with no traffic control. So uncontrolled locations where bikes and pedestrians are trying to find a break in the traffic. They're trying to estimate how fast motorists are approaching, and they're trying to make a break for it. So that's a very dangerous condition that this report has identified and is going to try to help address. Motorist speed, 30 to 35%, 30 to 35 mile per hour roads are where we see 26% of the crashes. And then also, I think no one's surprised, lighting plays a huge role. A lot of crashes are happening at night. The presence of street lights is very important, especially when you think about those uncontrolled locations where there's less likely to be lighting because there aren't traffic signals. So some of the other references and guidelines that this report references that exist today: FHWA, PedSafe, and BikeSafe web resources. There is the AASHTO bike guidelines. ITE has some context-sensitive design manual around multimodal systems. And then the FHWA STEPS program recently came out with pedestrian safety at uncontrolled crossing locations. So these are all really great resources that this guide references. However, there's some holes in some of these. I think a lot of practitioners know a lot of the countermeasures that are out there because they're kind of thrown at us. So we know of a ton of different things we can do, but we're not really told the process for selecting the proper countermeasure and the research behind it. So using this guide, the guide is set up so each chapter is a different step in the selection process. So it creates a framework for improving bike and ped safety at intersections. So the first step is framing the decision-making process. As this FHWA quote states, this is from some educational material, our bicyclists and pedestrians are intended users of the roadway. 10 years ago, you might have been able to say, well, this street wasn't really meant for pedestrians, so that pedestrian shouldn't have been there. You might have been able to get away with that in the past, but things are changing, and liability is changing. So by not addressing these sorts of crashes, local jurisdictions are really putting themselves at a huge amount of risk for liability. So framing a little bit some of this question, this kind of steps away from the guidelines themselves, and this kind of is, I would say, sort of my advice for reframing how we think about these issues. Historically, or the last 5 or 6 years, engineering, education, and enforcement has sort of been the mantra for safety improvements, which is okay, I think. But I think it creates silos. So as an engineer, I'm only in charge of engineering, and then I can say, well, I put in a crosswalk, so it's up to the police to enforce it. Or it's up to the advocacy group to make sure that drivers know to yield to pedestrians. But at school, we're starting to think about it a little differently. We kind of created our own E's, ethics, empathy, and equity. So applied to an intersection like this, it's a school zone, 40 miles per hour posted speed limit, 40,000 cars a day at a 7-lane crossing. And, there's single-use family housing on either side. There's a bus stop. And so when you look at this from an ethical standpoint, there's a crash that occurs here. There's no marked crosswalk, say. Is it ethical as an engineer to simply mark a crosswalk here and say, okay, that's good enough, let's go on to the next issue? So thinking about these questions ethically, I think we all know that our system, our transportation system, and the decisions that we make have an incredible amount of bias towards motor vehicles. For the last 100 years, we've designed roads that prioritize vehicles and disregard pedestrians and cyclists. And also our regulations and rules largely still prioritize motor vehicles. So thinking a little bit about, as an engineer and as a planner even, kind of the ethics of the decisions that we're making. Empathy is a huge component, of course. So would you feel comfortable crossing the street? Would you feel comfortable with your, 10-year-old crossing the street? Maybe they're trying to get to school, or maybe your high schooler is trying to get to that bus stop so they can get to wherever they're going. So really thinking at these issues from an empathy standpoint. And then, of course, equity. I think people might see equity as kind of a buzzword right now, but I think it's more than that. Thinking about this street was built for motorists. If you're driving on the street, it is so comfortable. You've got your kids in the back seat, you're driving with your friends, you're listening to the music. However, if you look in your rearview mirror for 5 seconds and take your eyes off the road and a pedestrian's trying to cross the street here, you may cause a fatality. As a driver, you're kind of expected to make mistakes. It's built into the system. It's built into how your car is built. The airbags, the onboard controls, the width of the roadway, the warning signs that warn you about upcoming issues. But if you make a small mistake as a motorist, you're probably not going to die in this situation. But if you make the tiniest mistake as a pedestrian or a cyclist on this type of road, you're at a huge risk of being seriously injured or killed. So we really need to think about reframing how we look at safety projects on our streets. This is an example of that. So this is something that happened in Asheville. A babysitter was trying to cross the street with her, 2 children, and they were hit and killed. And the babysitter was blamed. Why would you have 2 kids on the street? Why would you try to cross where there's no crosswalk? Well, there's a shopping center, there's a bus stop, there's a sidewalk, and you need to get across the street, but there's no pedestrian heads, there's no marked crosswalk. And so thinking about why these crashes are happening, rather than blaming the people that are involved in them, is very important when you think about framing this process. So one thing that I really like about this guide is that it talks about reactive versus systemic safety. So historically, we've been really reactive about safety. We wait for a tragedy to happen on our streets, and then we decide to take action and mitigate that particular intersection, which actually works okay for motor vehicles. When you look at a specific intersection, you have a wealth of crash data. You can look at crash data from the last 5 years. You can see what the patterns of crashes are, and you can really easily select countermeasures to help prevent those crashes in the future. For pedestrian and bike crashes, fatalities, that's much more complicated. Just because a fatality happens at one intersection doesn't necessarily mean that there's going to be another one in the next 5, 10, 15 years. Many cities might see 4 or 5 pedestrian crashes in a year. So by fixing one location, you might not actually be preventing another serious or fatal crash at that specific location. Also, there's no crash data, right? All of our crash data are from motor vehicles. Pedestrian and bike crashes are drastically underreported, as we all know. So if there's a fatality at an intersection, it's highly unlikely that you're going to find any previous data to use to help determine what that mitigation factor is going to be. So this guide helps to create a new system of systemic safety. And the idea behind that is, a crash occurs at this intersection. You look at the risk factors for that intersection. So there's a lot more data that you collect besides just crash data, a lot more contextual data. And then you use that data to determine other locations in your transportation system where there are high risks before those crashes occur. So chapter 2, identify and collect data for analysis. As an engineer, my first question is always, what's the ADT on a street? What's the posted speed limit? And what's the actual speed? So that's all motorist data. It does help me to make some contextual decisions about what's happening on the street. It's also the most readily available data, but that's not enough data to really help inform decisions for mitigating safety issues. So this guide really dives into other types of data that can be useful. For example, crash data, obviously, it talks a lot about exposure. So the ADT of motor vehicles helps you decide on the amount of exposure that bikes and PEDs are experiencing. Things like turn volumes also help with that. So the infrastructure geometric design is very important. So it tells you how to look for certain issues there. Signal operations, intersection control, of course, speed, and then, those conflicts that are happening. So this guide really dives deep into collecting data. Data is so important. We talk about defensible data-driven decisions, but I don't know if we talk enough about the quality of data, tying data to the purpose of our safety project, and then afterwards evaluating that to make sure that we've accomplished our goals. So one thing that this guide also does that I really like is that it dives into the top pedestrian and bike fatality types, and it walks you through what is happening for each of those types. So for example, bicyclists riding through a signalized intersection on a red light, that's about 15% of fatalities. That's really high. I think a lot of people may say, well, of course, bicyclists aren't following the law. They never do. They're just running through the intersection. But as an avid cyclist, I know, and knowing human nature, you don't have to be a cyclist to know this, but like, bikes, people on bikes aren't just blindly blowing through intersections with their eyes closed, hoping that traffic isn't coming. There's more happening here. I know that cycle lengths are timed for motor vehicles, typically, bicyclists and pedestrian, they don't like to wait more than 30 or 60 seconds before they try to find an opening in traffic to go. So retiming those signals is important. Also looking back at that crash data that is really not as useful as it should be. You may know that a crash happened at an intersection, but you don't know if there weren't bike facilities there. You don't know where that bike was. If there was a bike lane, they might have been in the bike lane. If there's no bike lane, they could have been traveling on the sidewalk. They could have been trying to use the crosswalk to cross with a pedestrian signal. There's a lot of things that could be going on. So this guide kind of helps frame some of those. And then chapter 3, analyze intersection safety and identify issues. So there is no systemic guide yet for bike and pedestrian safety, kind of thinking of that proactive approach, but past research can still be used to identify risk factors that have been found to impact safety. So the guide has some information on that, which can be helpful, kind of positive and negative correlation to safety. And so this is also kind of looking at that proactive approach. So when you look at this when you look at this bike facility, like the street's pretty good. It's got, you know, wide sidewalks. It's got a bike lane. Transit's happening. It seems like a pretty complete street, right? But when you really look at it, you know, you've got these two girls that are trying, you know, that are riding down the street, and there's no factor of safety for them here. So if a car opens their door and they get doored, they're flying into a bus, right? If a driver is distracted for a split second and starts to veer into the bike lane, you know, they're getting hit. So really thinking proactively about our streets and how we can make them more safe before a tragedy occurs is really important. So one way that this guide helps to address some of those issues is that it starts to think about contextual countermeasures, and it incorporates that factor of safety that allows for all roadway users to make mistakes. You know, we're all human, we're never perfect. So that context for this guide is done by creating 3 different tiers of mitigation. So the first tier is something that supports motorist yielding. Number 2 requires intervention to induce the motorist yielding. And tier 3 completely separate the modes or require motorists to stop. And so when you look at this chart, you've got the ADT up top, and then you've got the number of travel lanes. So when you look at 4 lanes with raised median and you've got ADT greater than 15,000, this is actually, this chart is saying that you're at a level 3. You need to separate your modes or require motorists to stop. So for the intersection that we were looking at previously, this guide is telling us that it's a tier 3. And if you want a high level of effectiveness for reducing the likelihood of crashes at this intersection, you're going to have to get pretty severe grade separated crossing. So build a bridge or dig a tunnel, channelizing fence or barrier, just completely preventing pedestrians from using the space. You know, your first question of any project should be, do we want bikes and peds to use these facilities? And sometimes maybe that answer is going to have to be no, and you have to find some other way to accommodate them. Maybe it's directing them to a signalized intersection that is safer. But then maybe, you know, you're not ready for any of these. You just really don't think that those are feasible. The guide also gives some more moderate mitigation strategies. So, you know, signalization, something that suggests, you know, beacon that may suggest to motorists, hey, there's a pedestrian crossing coming up, please yield, and things like that. So your likelihood of success is going to be lower with the moderate buckets, but you may be more likely to implement something. So this guide takes that into consideration. Let's see here. And then, so identifying treatment options for creating safer intersections. This table is really helpful because depending on the type of crash that you're seeing, you can determine there's different things in here, such as, you know, determining the amount of public process that's required. Very helpful to know from the onset. And you can kind of see whether, you know, your level of, look, I really want something that is really high. This is a really big issue. So this table can help you select the proper strategy. So a bike signal in a situation where it's tier 3, you know, you're going to have you know, bikes that ride through the signalized intersection, you're going to be able to mitigate that issue. And then also the guide jumps into land use context, which is very important. So, you know, we were talking about fences. In a downtown urban environment, you're not going to get away with putting up a fence and a no pedestrian crossing sign. But maybe further out in a suburban area where, you know, the land use patterns are much different, you might be able to get away with that. You might need to direct people to the safest place. So this guide also takes that into consideration, which is kind of unusual. A lot of guides are just starting to think more about land use and sort of connecting the planning and engineering pieces. Chapter 5, let's see, where you're refining your countermeasure options and kind of trying to select, you got multiple options at this point, so which one's going to be the best for you. This guide goes into how different treatments overlap or how they may be solving the same problem in what they do. So when you have an intersection where you really want to get bikes and peds out in front of motor vehicles because you're having some mixing issues, you may be able to select an LPI, lead pedestrian interval, and maybe you direct bicyclists to use that. Or maybe you just want bikes in front of cars and a bike box is a good mitigation strategy. So this really gets into that granular detail of the different types of the different types of mitigation strategies. Numerous counter, this is kind of the same thing, predominant crash types and numerous countermeasure options may be effective. So things like speed tables and then, bump outs. Again, you're solving for different things here. So it gets into that. Also talks about budget. As a practitioner, I really appreciate that. How much is this going to cost? How much is it going to cost up front? And how much is it going to be cost to maintain? On the right, you can see a really nice painted bump out. It very much looks like an extension of the sidewalk, and you've got some white flex posts. So that may be a first step that you want to last for 4 or 5 years until you find your funding to do some bigger overhauls, which may look like what's on the left here. And then this, at the end, there's also countermeasure glossary. So talking about each of those countermeasures, also giving a crash modification factor rating. So you're really seeing how effective these are. One thing that I think I found really interesting is curb extensions. There's really not much research indicating that curb extensions are really effective from a safety perspective. So when you're looking at a crossing island, one of those pedestrian islands in the center of a street, or a curb extension, I personally would choose a pedestrian crossing island every time. But agencies really like curb extensions because they're easy and they might reduce the amount of parking that needs removed. So like if you're taking the easy way, that may be where you end up. But this guide can help you as a practitioner say, no, we should do something more than just curb extensions. That's not really getting us where we need to be. And then trade-offs, of course, always a big question. So this table shows all of the countermeasures and then gives you an idea of the estimated cost, the maintenance cost over time. Public process, is this something you want to install tomorrow, or do you have time to really talk to the public and get their perception of what's going on at intersections? That's something that I did not talk about, but qualitative data collection is very important for bike and pedestrian safety. As engineers, we want quantitative data, but really it's effective to get out there and figure out what the near misses are, how users of the roadway feel when they use it, since we are lacking a lot of that quantitative data. And then it just talks about the trade-offs of each one, whether pedestrians we'll see a decrease in operations or, motorists will, that sort of thing. So this is a really good one-stop shop for all of that information. So yeah, that's the summary of the guide. A link is available to it on the NCHRP webpage. So the link is right there. I believe it's free for download to view. So I recommend everybody take a look at it. And there's my contact info if anybody would like to follow up on me, have any questions. So thanks so much. I'm going to hand it back to Joe.
Thanks, Katie. And I guess I forgot to mention at the beginning as well. We're going to be sharing the questions and answers at the end. There is the question and answer box. So if you do have any questions that you would like Katie or Bastian to answer, please feel free to put them in. They may answer them as they're going along, or we'll try to have a few minutes at the end that we'll pass them off to each of them to answer your questions. So in order to keep us moving along, I'm going to introduce Bastian Schroeder. He's a recognized leader in the transportation industry who is helping guide transportation emerging trends and technologies. His area of expertise includes traffic operations on surface streets and freeways, pedestrian accessibility issues, pedestrian bicycle operations, multimodal design, safety studies, and specialized field data collection. His background includes conducting research on behalf of the National Cooperative Highway Research Program, Strategic Highway Research Program 2, Federal Highway Administration, Institute of Transportation Engineers, and the National Highway Institute. He's participated as author or co-author in publishing over 70 journal articles and conference proceedings, and has given numerous presentations at state and national conferences. Everyone, please turn your attention to Bastian. Take it away.
Thank you, Joe. And can you all hear me okay?
Yes.
Excellent. I have been, my computer crashed about 20 minutes ago while Katie was speaking, and I'm still not back to the server. So I am sharing a PDF of the presentation. So I'll apologize. Some of the animations that I had in there will not work in the PDF, but in the interest of moving along, I'll stick with this. So what I'll talk about is another NCHRP project, Project 0725, which is about to be published as NCHRP Report 948 in the next month or so. And it's really as Katie mentioned in her introductions, it's maybe zooming in a little bit at the intersection level. So it's really looking at pedestrian and bicyclist safety. That's one of the edits. So we're not making sure that the bicycles, like the metal frames, are safe, but the bicyclists, the people on the bikes, that they are safe. At alternative and other intersections. This project started really with a look at the alternative design. So the diverging diamond, the median U-turn, the arc cut, the displaced left turn. But we very early on in the project recognized that it is not very helpful to have a method that can just look at the alternative designs if we can't also compare them to an alternative or to a conventional design. And so that's really what this guide is all about. So while it has a lot of information about the alternative concepts, the method that I'll talk about is really much broader than that, to where it can help in the planning and design stages really of any intersection. The key with this approach, and really any intersection design, is that it's iterative. And so here's a chart that we borrowed from NCHRP Report 785, the performance-based design process, where you should go into a design with a certain set of intended outcomes, which presumably includes your traditional design characteristics for, sight distance and fastest path for a roundabout, and and design vehicles, turn radii. But really what we're advocating for is really bringing in the pedestrian bicycle elements really early on. You come up with your initial design and then you iterate. And in order to allow for that iteration, you really need performance thresholds or some sort of a metric that you can use to evaluate the effectiveness of that design for pedestrians and bicyclists. And that really is what this report is all about. In the project, we talked a lot about ICE policies, so intersection control evaluations that many of you may be familiar with. PennDOT has an ICE policy, many other states have as well. And so really what we're looking to do with this is integrating the considerations for pedestrians and cyclists very, very early on in the design stage. We looked at intersections throughout our projects where, for example, we came to the conclusion that really a separate bicycle facility is probably the best thing to do. It's the safest thing. And then we're told, well, we don't have the right-of-way for it. And that's the kind of challenge that you're running into if you're kind of going with an accommodation approach, right? So looking at pedestrians and cyclists late on in the stage, you have your curb line set, you have right-of-way set, you have drainage all figured out, and then you're all of a sudden, oh, how do we get pedestrians across the street? How can we have cyclists travel through this intersection? So really the idea is, let's integrate the multimodal users into the design process really early on, even at the alternative selection stage, to then have more flexibility, because early on in the project you still have flexibility in the design decisions. Later at a 75% design stage, you really don't have many choices anymore. So at the heart of this project is what we call the 20 flag method. So it's really 20 safety considerations for pedestrians and cyclists that more often than not are associated with injuries and fatal crashes. And so really what this method does is let's evaluate all 20 of these. And I'll introduce you to a few of these in this presentation. The flags are divided in what we call yellow flag and red flags. So there's something for the soccer fans in here. Yellow flags are the ones that are impacting user comfort. So level of stress, the quality of the experience for walking and cycling, but maybe not being directly tied to a safety concerns. That's where the red flags come in. So those are the ones that are directly tied to safety considerations. Both are undesirable, but both exist at intersection. And so what this method does, it flags these. these and highlights where they are. The method is applied on the left for cyclists, really assuming cyclists operate as vehicles, so on the roadway, so the 4 through movements, 4 right turns, 4 left turns for standard 4-legged intersections. And for pedestrians, we're looking at the crossings between the 4 quadrants. Obviously, this is modified for a 3-legged or a 5-legged intersection. And cyclists who use the sidewalk environments, maybe children, they would be evaluated as pedestrians. The research provides a checklist, so really a scoring sheet where the idea is each of these cells is evaluated, and each of the flags further has thresholds. So there's a table provided that you can use to then look up, is this a yellow flag or is this a red flag? This is our goal. Our goal is to be able to compare, let's say, 4 alternatives, so 4 different intersections, and in addition to all the assessments for motor vehicle safety and level of service and delay and queuing and all the things that we typically look at, let's give it a pedestrian assessment and a bicyclist assessment, where we can see in this case that alternative C is really the best from a multimodal safety perspective. Does it eliminate all red flags? No, it doesn't. But is it better than, for example, alternative D, which has a significant portion of safety concerns for pedestrians? Yes, it is. And so the idea is that once we have this initial assessment, we can now iterate and seeing if we can mitigate some of the design flags. And the report talks about many different strategies, from countermeasures, treatments, RFBs, pedestrian hybrid beacons, race crosswalks, maybe even grade separation. But by putting this on the table really early on, we can, it might be that from a vehicle level service perspective, maybe alternatives C and D are more or less equal. Then this can give you the argument, well, let's go with C because it really works much, much better for pedestrians. So let me give you a few examples of what these design flags look like. Obviously can't go through all 20, but one of the ones we look at is motor vehicle right turns. And so really a right turning vehicles has typically 2 kinds of conflict. It has the near side crosswalk, so at the upstream end of the right turn, there's a conflict that typically occurs with a right turn on red movement. So an easy mitigation is to not allow right turn on red. And then the downstream crosswalk has a conflict that happens during a right turn on green movement, when typically those pedestrians would also have the walk indication. The severity of that conflict is a function of the vehicle speed and the vehicle turn volume. If this right turn is very slow design speeds, then it is generally much safer, and it might not be a flag at all, as when it is a very large swooping right turn with really high volumes where vehicles really just are able to fly around the corner. This design flag happens at conventional intersections too, right? And so here's just a few examples. On the bottom left is an intersection where you see 2 very different corner treatments. So on the eastern approach here, you have really tight corners, and that's because this is a one-way street. So the designer didn't expect vehicles to turn, and so they made the turn really tight. Versus on the left, on the western approaches, you have these really wide swooping turns. So all else being equal, those faster turns are a much bigger concern than the tighter turns. Bottom right is an intersection in Boulder, Colorado with channelized right turn lanes, where 3 of the turn lanes actually were retrofitted with a raised crosswalk. So again, the channelized right in this case was actually introduced as a bicycle safety treatment to eliminate or help with some of the right hook crashes. And so then it introduced a pedestrian safety concern, which was then mitigated by putting a raised crosswalk. The goal of our approach is to help quantify these things. Another movement that happens frequently at alternative designs, in this case a DDI at diverging diamond interchange, is pedestrian crossings of yield-controlled or uncontrolled vehicle paths. So for example, the right turn onto the freeway here, and then the left turn onto the freeway, you see from a vehicle perspective, this right turn movement yields to the left turn movement. So having pedestrians cross a free-flowing left turn as vehicles accelerate to freeway speeds is a very, very challenging maneuver. But this also happens at conventional intersections. So here's another example of 2 channelized right turns, especially the ones with an acceleration lanes, where those movements might happen at a really fast speed. Another flag is multi-lane crossing. So, and whenever pedestrians have to cross multiple lanes of traffic, there's more exposure. Katie had some of those examples in her presentation, and so that is something we see at alternative designs, and also we see at conventional intersection. Sometimes you see a really short crossing here, just 2 lanes, versus just on the opposite approach where you have a dual right turn, you have a bike lane. So all of that adds to pavement and exposing pedestrians in their crossing. And then here's an example of a cyclist flag that happens frequently at an R cut, as is shown here, where a cyclist trying to make that left turn in a traditional R cut configuration is expected to go through the intersection, weave across 2 lanes of vehicle traffic, and then go into this U-turn bay to travel back. So the thought of a cyclist changing lanes with traffic going at 45, 50 miles an hour becomes a very, very challenging environment. But this happens at conventional intersection too. So here's a bike lane that you can kind of see through the trees, downstream left turns. In this particular case, the cyclist has to make 1 lane change to get into the turn pocket. Are those 2 the same? No, they're not. And then this is what the method, so it flags the movement, but then it also rates the severity of the conflict based on the vehicle speed, the volume, and then a few other considerations. So I wanted to relate all this to a study intersection that is in Wilmington, Delaware, and it's a conventional intersection. So this is the intersection of Falkland Road and Center Road, kind of on the outskirts of the downtown area, for those of you who might be familiar with Wilmington. And if you look at the aerial, it looks like, well, it has all the pedestrian bicycle features in it, right? So it has channelized lanes, it has really high contrast crossings, it has sidewalks on all of the approaches. There's actually some bike lanes going through on the east-west approach. So the question is this intersection safe? And you know, in this particular case, we're actually asked to look at this intersection because there was feedback that it was not safe. And so let's test it with the method to see what we can find out. So we started with just looking at maybe the general activity. So looking at the STRAVA heat maps, looking at really a pretty heavy east-west cycling movement. So this is a cycling commuter route into the downtown area. And then from a pedestrian perspective, you see some activity. And again, especially this kind of right turn seems to be quite heavy, but also this crossing of the southern leg, which connects a neighborhood with a gas station and other retail. Again, similar example to what Katie shared, right? So pedestrians do cross the road, you know, go into a gas station, go into a convenience store, go into a restaurant. These are very common movements. And so I'll present 2 ideas, 2 just design alternatives, and I'll give the disclaimer that this is very much some early concepts. You know, these are hand drawn; they're not done in CAD, but I wanted to at least give you a sense of how this method is applied. So if we start with the existing conditions, and this is where the animation would have otherwise come in, and so it looks a little bit crowded now because everything comes in at once. So just a few things to highlight. Over on the left is when doing the 20 flag assessment, these are the flags that were highlighted in the assessment. And so the first one is a red flag, so it's the motor vehicle right turns. So in all of these cases, the vehicle right turns are quite fast. They're also heavy volumes, and so those are all concerns raised for pedestrians. Crossing the yield-controlled path, this is actually down here. So when a cyclist moves through the intersection, they go through a vehicle movement that is only controlled by a yield sign, and so there's a concern that the vehicle, you know, flies around this corner and then has a cyclist that they need to yield to, but the vehicle may or may not be paying attention to them. Multi-lane crossings. Pedestrians have the equivalent, if you start counting here, of 2 through lanes, 2 left turns, a median, and 2 opposing through lanes. So really a 7-lane crossing, unexposed, without any kind of refuge. There's driveways, so 4 driveways that pedestrians have to interact with. There's some sight distance concerns. For this particular one, a pedestrian trying to cross, when they look over their left shoulder to look for a gap in traffic, there's actually a line of tree and there is some vertical elevation here that makes it really impossible to see the approaching vehicles, and vice versa for the drivers to see the pedestrians. It's curious, in the AASHTO Green Book, we very routinely check for sight distance for vehicles, right? We look for stopping sight distance, we look at intersection sight distance, decision sight distance. We're quite scientific when it comes to evaluating that. Yet we don't have a pedestrian crossing sight distance. Why do we not check whether if a pedestrian needs a 7-second gap to get across the street, why don't we check whether that pedestrian can see 7 seconds upstream to make sure that that gap is actually provided? Riding in mixed traffic, so we have cyclists that are in a bike lane with fast-moving traffic on both sides of them. Bicycle clearance time is a flag that looks at if a cyclist really does what they're supposed to and they go through the intersection at the end of yellow, same with the vehicles. Our all red time is timed assuming the speed of a vehicle, in this case 50 miles an hour. What that really means is that by the time the signal changes to the opposing direction, the cyclist will be in the middle of the intersection because the cyclist is going maybe 15 miles per hour, maybe even 20, but certainly not 45 or 50. And so that means they're literally in the middle of the intersection when the opposing direction gets green. If they then barely make it through, they then get to this turn lane where these vehicles are now unopposed from other vehicle traffic because north-south is green. So these vehicles fly around when the cyclists go through. So taking a look at bicycle clearance times is really important. Lane change across vehicle lanes means a cyclist that is trying to make a maneuver from west to north, they have to travel in the bike lane, cross across 2 lanes of traffic that is moving at 45 miles per hour or faster into this turn lane, so that's a flag. And then finally, this channelized lanes. So for cyclists, they spend a significant amount of time in these, cattle chutes where, probably around 10, 15 seconds that it takes a cyclist to travel through this channelized lane, while vehicles that are much faster are also in that same lane with the risk of them overtaking it. This is still relatively short. This flag really was introduced when we look at, for example, a displaced left turn or CFI, continuous flow intersection, where cyclists sometimes are in these very, very long channelized lanes. So here's what that assessment looks like. So at the first look at the intersections might suggest, well, we have bike lanes, we have sidewalks, we have marked crossings, we have high contrast pavements. But when we really run it through the assessment, for pedestrians, we have 31% of the movements experiencing a red flag and 23% of cycling movements experiencing a red flag. So really some significant concerns. So let's roll through a potential mitigation. Again, apologies for not having the animation in here, but I'll just kind of go through these. So our first look at the intersection was, what can we do with a low-cost treatment? And so there's 8 strategies here that all happen within the curbs. We're not changing curb, we're not changing drainage. We're really looking, what can we do? The first is we widen the cut-through islands. They currently are at the minimum of 5 feet, which is required by ADA. The islands are plenty wide enough. Let's give pedestrians a more comfortable environment to wait. Maybe there's multiple pedestrians. Maybe it's a cyclist pulling a bicycle trailer behind them. So let's widen the island because we can. The next is install raised crosswalks. So in all 4 of the channelized lanes, if this is here for capacity treatment, or if this is here for providing a turn radius for a design vehicle, let's slow the vehicles down. They don't need to go around this turn at 35 miles an hour. So the raised crosswalk will provide better crossing opportunities for pedestrians. Third, striping the bike lane through the intersection, providing that positive guidance for cyclists as they're going through the intersection so that they know where they are, and that drivers also have the visual confirmation to expect cyclists. 4 is a really important one, adding a 2-stage left turn. So instead of a cyclist weaving across traffic, have them go through the intersection, pull over to the right. So in advance of the stopped vehicles outside of the crosswalk, they can turn their bike 90 degree, and then with the north-south green, they can then go through the intersection in a safe movement. You can further help those cyclists by giving them an LBI, a leading bicycle interval, to where they can actually get a head start of that stopped traffic. 5, consolidate driveways. We have 4 driveways that are all within the area of influence of the intersection, including one that allows a direct left turn as vehicles and cyclists are trying to navigate this channelized lane. So really a high conflict location here. Those vehicles have another opportunity to get into the same shopping center just a little bit downstream. So let's separate the conflicts. Our experience is that whenever we overload drivers and we give them too many decision points at once, in this case, looking at vehicle gaps, looking at driveways, navigating the turn lane, and then you put a cyclist in the middle of it, the cyclist is the last thing that drivers are going to pay attention to. So let's make it easy for the drivers by separating the conflicts and simplifying the decision making. For the 2 driveways we keep open, obviously we do want this gas station and the other stores to continue to be serviced, but let's provide some channelization. So rather than it being wide open, building driveway islands to break up the crossing and make it clear for vehicles that are entering and exiting those driveways to expect pedestrians there. Another really low-cost treatment is install stop signs at the end of the channelized turn lanes. So at all 4 locations, having drivers that go through the turn lane stop first. That way they have a moment to look at and evaluate whether a cyclist is maybe going through and preventing that. And then finally, taking the refuge islands at the intersection and pulling those out forward to provide these kind of these bullet noses, so some positive protection. It's still a long crossing, but you're breaking it up into a 2-stage maneuver, at least in the pedestrians' minds. It also helps whenever there are permissive left turns, for example, that they have to really go around the way that they're intended to, following the skip lines, as opposed to cutting through the pedestrian space. And with that assessment, we're eliminating all red flags for pedestrians, and we're really reducing the bicycle red flags quite significantly. The other more drastic, since we were talking about alternative designs, is this one. So going to a median U-turn, and so this is a wholesale redesign of the intersection, taking all the vehicle left turns and moving them to the U-turn configurations, taking out all the channelized right turns and having them just a slow right turn here, providing much more pedestrian space, and then bringing in either on-street bike lanes or even better, and I didn't want to redraw this after the assessment. It's probably even better, given the volume and vehicle speed, to have some sort of a protected facility, so a cycle track facility or even a separated shared use path to get cyclists through the intersection. But as shown here, plenty of room within the right-of-way. This is a generally pretty low vehicular volume intersection, to where taking out the direct left turns, we don't think would result in a much deterioration of the level of service for vehicles. And so this approach, again, similar, better performance for cyclists. So we're going to 4% red flags for cyclists. It does leave some concerns for the pedestrians, and those are shown here. Still some right turn concerns, some delay concerns. So taking it all together, we went from a relatively small assessment or short duration, maybe about an hour or so. We were able to quantify the conditions of the as-builts, as well as 2 alternatives, and really seeing that the method is sensitive to these trade-offs. So alternative 1, which is the low-cost one, actually gives the best performance for pedestrians, leaving some concerns for cyclists. A wholesale redesign works a little bit better for cyclists. Ultimately, as I mentioned in the beginning, you may not be able to eliminate all the red flags in an intersection, but just having the awareness and having it part of the consideration is ultimately what we're looking for. So a conscious decision that just marking a crossing, just providing a painted bike lane does not necessarily mean it's safe, right? So we want to really get to the why behind why we're doing a particular treatment, and that's what the method is intended to do. And then from here, it becomes an iteration. right? So now that we've done this initial set, we're seeing, and this is where as engineers and planners really our creativity can come into play. What else can we do? What are some other ideas? What have we seen other agencies do? You know, we saw Katie's report that talked about protected intersections. Maybe that is something we can do. So really giving a basis for that decision making, where we feel very strongly that we are able to come up with intersections that meet the performance criteria for vehicles that are satisfactory from a fastest path, from a design vehicle perspective, the turn radii, that give us the proper level of service, that give us the safety performance. But let's integrate pedestrians and cyclists into that decision-making process from the beginning when it's still easy or easier for us to actually make changes to the design. So with that, I'm happy to take any questions. Thank you for your time.
Thanks, Bastian. I do see there's a couple questions in the question and answer box, so we'll try to jump through those. I see there's a couple that were in there that Katie already answered, but a couple of these other ones that have come through here. We had a question that is the STRAVA heat map available to all practitioners, and is it only for certain areas, or is it separate software?
Yeah, great question. So I think the URL was in there. This is a free service, so Strava makes it available. There are pieces of this that you can purchase. I'm glad you asked the question because there's a really important caveat with Strava heat map. It is active users who use their phone. You can't see my phone because of the background. So it's active users who use their phone to track their physical activity. So one of the big concerns that I would have of using a source like Strava is it really representative of the full populations of pedestrians and cyclists, right? So Katie mentioned the new ease. She mentioned equity. That's a really important one, right? So there are certain demographics that are very unlikely to do an exercise trip using Strava, and that's the only part of the data that's captured. So it's useful. I've never been to Wilmington, Delaware, and was asked to look at this intersection, so it was useful for me to wrap my head around what this intersection, what the usage might look like. But as we're doing an assessment of our conditions, it's really important to get a true sense of all the users out there. And really, you know, for an intersection like this, I would have wanted to do, you know, local stakeholder engagement, you know, talk to the local engineers and planners, talk to the residents to really understand what the usage characteristics is. So this was a kind of a shortcut for me to understand what's happening.
Okay, thank you. And another question that came in said many members of bicycle coalitions or bicycle rights advocates pages on Facebook have complained that planners and designer improvements at intersections are not nearly as practically helpful as actually reducing the posted speed of the vehicles. But this is often pushed back against by municipalities and engineers. Any thoughts on this?
Well, I'll share, and I'm sure Katie has some opinion. I do believe, this is my personal opinion, this is not in the report, but I do think my personal opinion is that the vehicle speeds in this country are very, very fast. And we think it's a given, but I don't know that it necessarily needs to be. I grew up actually in a small town outside of Frankfurt, Germany, where the neighborhoods and the streets that I walked in as a kid had a maximum speed of 30 kilometers an hour, not miles an hour, so about 20 miles per hour. And our main street through town was 30 miles per hour, and that was a two-lane road, and it had signals to help pedestrians get across the street. If I take for comparison, you know, the idea that in order for my kids to walk to school, they have to walk along and cross a road that is 45 miles per hour, drops to 35 in the vicinity of the school, it is very fast. So I do think it is true that speed has a tremendous impact. And I think there's two parts of it. I think with right-of-way for the travel between intersections, we have the luxury that European countries don't have, which is providing separate facility. We have more room in at least many parts of the US. At intersections, I do think that there are speed reducing treatments like the raised crosswalk. When we looked at accessibility at roundabouts, for example, we found that in many ways a raised crosswalk was as effective as the pedestrian hybrid beacon, which is touted as, you know, the treatment to make roundabouts accessible. But really we found speed reduction has a very similar effect. So I do think it's a little bit of a change in mindset, but that as we're looking at really re-envisioning our intersections, as we're looking ahead at the next Green Book, more of a context-based approach approach to design, that there are many parts of where we walk and cycle where maybe we don't need to also be driving at 35, 40 miles an hour.
Yeah, I guess I would add, from the municipal standpoint, you know, a traffic engineer may get a report of speeding on a street through a 311 request. And in the past, they may just respond by putting up a 25-mile-per-hour speed limit sign. And in the past, that hasn't been proven to actually reduce speeds. And so there's sort of this mindset that setting a changing the speed limit doesn't affect motorist behavior. I think that recent research from cities that are reducing the speed limits, you know, Portland and Seattle and other cities, the data is coming back that is having a larger impact on motorist speeds. But I think that's part of a larger conversation of, you know, things like 20 is plenty and having a really citywide effort to reduce the speeds. You know, 25 miles per hour on a residential street where you have a lot of things happening on the street at a neighborhood level, 25 miles per hour is way too fast. You need to be going about 15 miles per hour to be able to react to a kid playing on the street, a ball going across the street, a dog running across the street. I do think that at the state level, states need to start thinking about those statutory speed limits. And so that's a larger conversation for sure. But I can see where some of the friction is, where some of the older traffic engineers are saying posting signage doesn't make a difference. But I think that they need to start looking at some of the research that's coming out of these cities that are having, you know, citywide conversations on these topics.
Sounds good. I know we're kind of running short on time here. We have just a few minutes, so maybe we'll try to do some quick hit answers with a couple of these. Another question we had was Bastian. You mentioned access management and closing driveways. From their experience, it's a large lift that sometimes jurisdictions don't want to touch, even though it can have several benefits. Can you speak to any guidance or success you've had with that?
Yeah, there's some really great resource out there. I mean, to me, the two big questions that I see come up with kind of driveway consolidation is one is kind of the business owner, the economic impact, which is probably what they're most concerned about. There's been a lot of national work. I was involved in a study with North Carolina DOT where we basically found that the economic impacts of access management, looking at a dozen corridors where a median was put up and some of the direct lefts were taken out, ultimately didn't have many long-term effects on the businesses and the vitality of the business. And I think for the specific case, talking about the example that I had shown there with the gas station, the shopping center, to me, it's a conversation of what the goals are for in this case, the business owner, and also helping them understand or the objectives from a bike ped perspective. On a per trip basis, a cyclist spends a lot more money on local businesses than a driver does. There's been lots of research. So helping the business owners understand that yes, drivers are part of who shops at our businesses, but cyclists could as well, and pedestrians could as well. If I had zoomed out on the map, there's neighborhoods all around that shopping center, right? And so there's a whole other population that could travel there and shop there and actually increase business. It's on a case-by-case basis, but to me, it's all part of a conversation.
So we got a couple more.
This is John, the PSU host. Unfortunately, I'm going to have to end the session. I want to thank the speakers and moderator and all the questions. Appreciate it for the information and all the participants. Thank you.
Thank you all. Thank you, John.
Thank you.